the call now. A lot of people still need to come in, but I'd like to say that this is a WISE focus group meeting. I will have a very brief introduction and go straight into the presentations. Our first presentation is from Cari Roper, and I will also note that to help us manage the Q&A, if you could enter your questions, comments, and reactions into the chat line. So, Cari, please go ahead.
Thank you, Chu. Good morning, everybody. I am Cari Roper. I'm a conveyance program manager and work in the engineering planning department at the Milwaukee Metropolitan Sewage District. I'm a civil engineer and have been working for the past 20 years. I've worked at MMSD for the past 13 and in my role for the past 2. So today I'll be presenting on using flow prediction for storage operation. So next slide, Cello. Thank you. MMSD serves about 1.1 million people in 28 municipalities. The service area is currently 352 square miles, and of which 24 square miles is combined sewer service area, meaning that those sewers in the area collect both stormwater and sanitary sewage. The district has 2 water reclamation facilities. The Jones Island Water Reclamation Facility serves almost all of the combined sewer area, as well as some separate sewer area surrounding. And then the other water reclamation facility is South Shore. It's located on our far south side and serves almost all the separate sewer area. Next slide.
You guys get big thunderstorm middle of the night?
MMSD has 2 large storage tunnels. The first, the inline storage system, or ISS. I'll be referring to the ISS throughout the presentation. That one can store up to 400.
I would just ask people to mute their microphones. Cari, we cannot hear you right now. You're muted, but everybody else mute their microphones if you're not speaking. Thank you.
All right, thank you, Cello. I'm sorry, I didn't realize I had been muted. I'll just start from the beginning here. Okay.
No, we just lost you the last few seconds. Everything
okay.
On this slide, yeah.
Okay, great. So MMSD has 2 large storage tunnels. The first is the inline storage tunnel. I'll be saying ISS a lot throughout the presentation. It can store up to 432 million gallons. It's 25 miles long and ranges from 17 to 32 feet in diameter. At its deepest location, it is more than 300 feet below the ground. The storage tunnel serves both the combined area and the surrounding separate sewer area. To dewater the storage system, a pump station that we refer to as the inline pump station takes flow from the ISS, and it can discharge to either treatment plant, although the ability to discharge to Jones Island is much greater. MMSD also has a second storage facility on the northwest side of the system. It's called the Northwest Side Remote Storage Facility, which is capable of handling 88 million gallons. This storage tunnel is 7 miles long, is 20 feet in diameter, and is about 150 feet deep. And this storage tunnel serves the separate sewer area on the northwest side. Next slide, Jill. Thank you. So this figure depicts the sewer system under dry weather flow conditions. The separate sewer is on the left side, and the combined sewer area is depicted in the center. So during dry weather conditions, both systems behave very similarly. Both systems discharge to their local municipal sewers, and then those discharge to a metropolitan interceptor sewer. Those are the sewers owned and operated by MMSD. We refer to them as the MIS for short, and those convey flow to the water reclamation facilities. Next slide. So during wet weather, the sanitary system continues to discharge into the interceptor system while stormwater discharges to nearby waterways. Some stormwater can make it into the sanitary sewer system as infiltration and inflow. So that does increase flow in the separate area. And then the combined sewer system takes both stormwater and sanitary flow. Flows from both of these areas still discharge into the interceptor system, and then any excess is then diverted into the storage system. Next slide. During extreme wet weather, overflows can occur. and they can occur from both the combined sewer area as well as from the separate sewer area. Next slide. So the following is a list of operating principles, and these principles are prioritized. The reason is because during wet weather, some of the principles must be sacrificed to protect the higher priorities. So overfilling the ISS and inundating treatment facilities are the two highest priorities, and they are not allowed. In wet weather, performing an in-plant diversion would be performed to avoid combined sewer overflows. Combined sewer overflows could occur to avoid separate sewer overflows, and separate sewer overflows can occur to protect against basement backups. So that's kind of the priority and operating principles. Next slide. So operation of the storage tunnel system during wet weather is challenging. Combined sewer flows include direct runoff during rainfall, so that occurs very fast. The system itself is closest to the interceptor system and the storage system, so those flows enter the storage tunnel first. Separate sewer flow includes infiltration and inflow, which enters the sewer system later in an event, and it is also farther to travel before reaching the interceptor system as well as the storage system. So overflow from the separate sewer area must be avoided as much as possible. The SSOs are not allowed. So the storage system must be able to reserve space for this flow. The challenge is, if too much is reserved for separate sewer flow, we may not be fully utilizing the volume of storage, which can in turn increase combined sewer overflows. So if you apply this to multiple events over time, you're increasing the frequency that you're having combined sewer overflows. Alternatively, if you reserve too little, then you're going to overflow from the separate sewer area. Next slide. So these are the physical elements depicted in this figure of the system, and that's what's controlled. So there are multiple locations that need to be operated during wet weather. The ISS includes 24 drop shafts. 16 drop shafts receive flow from the combined sewer area, 4 from the separate sewer area, and 4 drop shafts receive flow from both separate and combined. Combined and separate sewer flows to the drop shafts are isolated by sluice gates, and the gates to the drop shafts are the physical components that move during wet weather based on decision making during the event. The pump station is located at the Jones Island Water Reclamation Facility. Pumping out of the storage system can occur during a wet weather event if the facility has available capacity. So the first priority for treatment is, what's coming from the gravity influent flow. And then at Jones Island, pumping then from the tunnel is limited to the capacity of the treatment facility and what's coming in. And for South Shore, it's limited by not only the capacity of the treatment facility, but also by the force main and gravity conveyance system to get it there, because it's being pumped from Jones Island and then conveyed to South Shore. Next slide. So as stated, the operation of the storage system includes a series of gates that control flow into it, and combined sewer gates close first to reserve space for separate sewer flow. The available volume remaining is for separate sewer inflow, and so hence we have the term the volume reserved for separate sewer inflow, or the VRSSI, and we use that quite a bit. It is this value that needs to be predicted to help optimize storage operation. So the VRSSI varies between events. It's not very straightforward all the time. As rainfall changes with intensity and duration, antecedent moisture, lots of things can change. So it's very challenging to predict this value. Next slide. But a prediction is needed in order to help optimize the operation. And there are many different factors to consider when making this prediction. So I'm just going to name a few. We have, you got to predict the flow that will reach the drop shafts, but then you also have to track the volume within the tunnel in real time. So you have to kind of manage things as they occur, as well as kind of predict into the future. And then also just pumping out of the system. So because we can pump and we have the ability to pump, that has to be taken into consideration. Pumping varies, and that varies by how much flow is getting to the tunnel, or is getting to the treatment facilities. So that's all of those things compound into like how much can we really reserve. We've got flow coming in, flow coming out, and just balancing all of that while trying to predict what else is coming in. So it's a challenge. Next slide. So in the early 2000s, an algorithm was developed to help predict VRSSI, and this algorithm was developed using an artificial neural network system. The neural network system was inspired by living organisms. It has the ability to learn from examples. It can learn from a wide range of nonlinear dependencies. So a sewer flow and hydraulic model was used at the time to train the network in cause and effect. And from that, equations were developed that incorporated the measured input into calculated prediction. And the algorithm incorporated water level measurements at 3 flow monitoring sites and rainfall at 9 rain gauges. And then it also used predicted rainfall to generate a predicted VRSSI. So all of those things came together into a prediction. Next slide. So the predicted VRSSI is used as insight to the volume that may be needed during wet weather. And the district staff then use this along with radar, precipitation forecasts during wet weather to make decisions. So other factors I talked about, just inflows into the water reclamation facilities, those are also used in decision making. So essentially, decision is made by a team, but it is supported by technology and a defined process. Next slide. So several changes have occurred since the ANN system was developed. Improvements to flow monitoring and rain gauge networks and equipment have occurred in our system. Pumping capacity of the inline pump station was increased, so it's now 210 million gallons a day. 4 overflow sites were recategorized, allowing for a little bit more flexibility in operation at the drop shafts. As a result, the gate control strategy was modified for the drop shafts. So in the past, prior to 2012, there were basically 2 main steps to gate controls. The combined sewer gates would close, and then when the storage tunnel system was full, separate sewer gates would close, and everything would close at the same time. But now there is a sequential gate control procedure, and it prioritizes different locations. A select few combined sewer gates are prioritized, followed by sequentially closing gates in the separate sewer area. The highest priorities, the gates that are the last to close, are for locations that have the highest impact to the local collection systems and to properties. Next slide. So the changes that have occurred need to be incorporated into a flow prediction to more accurately reflect the current state of the conveyance, storage, and treatment systems and to provide more confidence to decision makers. There have been advances in the past decade or so on smart conveyance solutions, including machine learning, artificial intelligence. And we'd also like to take advantage of possibly doing other predictions to be considered with operation to aid in decision making during wet weather events. And hoping to also utilize predictions in machine learning and AI to develop operational strategies for other controls as well. We do have a challenge with dewatering the storage system and reopening gates after an event. If you open things too soon, everything could fill up again, so you want to time it appropriately that the event is truly over, and you can reopen gates and take in additional volume. Next slide. And so since the storage tunnel has been in use, MMSD has managed to capture and clean 98.6% of flow that enters the conveyance system. This has been accomplished using technology as a guide and experienced staff in operating the storage system. And so we are continuing to investigate solutions and looking forward to modifying and optimizing our operating strategy to bring this number closer to 100%. And that is it. So we can stop now, and then I think there's questions at the end.
Thank you very much, Cari. I don't see any questions in the chat line. So if somebody's interested in asking a question, you can. Just a second. There is a chat. You can enter it into Microsoft Teams meeting chat. I see that Mike Sweeney has raised his hand, so Mike?
Yeah, Chell, this is real quick, I think. Quick question. Yeah, I may have missed this too, Cari. I apologize. Are there any odor concerns or issues that you had to deal with the tunnel?
Not immediately, as far as I know. We do have some carbon filters, drop shafts, and we are reaching a point where there have been a few issues. So we're starting to do more regular replacements and just making sure we're keeping up on what's happening at each of the drop shafts in terms of odors.
Okay, thank you.
Yep.
Okay. It says you talked about the ability to make decisions on the operation. Is this real time during an event, or is it after events to learn more for next time?
Well, we're hoping for both. So the original ANN was for, real-time information on predicted flows to help make decisions during the event. What we're hoping to do this time is, well, number one, to look at real-time for operation, but we'd like to also keep some of the predictions in order to do some hindcasting and to really look at accuracy and how to make some of those predictions better. So that's what we're hoping to do as we move forward, looking into the machine learning and AI for this.
Thank you. Thank you for the question and for the answer. I have a limited ability to see if somebody raised their hand. So if you could type a message into the chat line. Does anybody have trouble entering things into the chat line? No, okay. So, Cari, you mentioned that you're looking into new things. Can you say a little bit things about where you are right now and with the efforts to improve on the next system?
Sure. Well, we've hired a consultant team to look at different options available that seem to apply to flow prediction. So there's a lot of AI machine learning capabilities out there, not necessarily directly looking at sanitary or sewage flow predictions. So looking into places that have done this in the past, but also, similar type of predictions that can help us develop a system. And so right now we're looking at demonstrations from different software companies and going through a process that we will be evaluating some of the pros and cons, some of trying to find a best fit for us. And then we'll move forward into an implementation following that.
Thank you very much, Cari. We'll move on to the next to the panel session now, and we have three distinguished presenters. We have Jennie, Chadick, Kaisra, Osman, and Nohemy, Revilla. They will take on from now, and I will go back to my clicking duties. So, Jennie.
All right. Thank you, Cello. Good morning, everyone. My name is Jennie Chadick, and I am the System and Asset Planning Manager for Tacoma Water. And I've been asked to share a little bit about why is asset management difficult, and then a success story we have in Tacoma Water. And so why is asset management difficult? This slide really demonstrates that nearly any activity in a utility organization might be considered asset management. I know for our asset management team in Tacoma Water, we've been pulled into everything from establishing project management best practices, planning our capital and O&M budget for the next 10 to 100 years, evaluating our asset maintenance strategies, process improvements to operations like what Cari just presented on. All sorts of different activities can be considered asset management. And I know for us at Tacoma Water, we're a team of 3 out of an organization with around 300 employees, and we can't, as a team of 3, nearly tackle this all alone. It involves many different people, many different processes, and many different competing priorities. Next slide, please. In addition to all the people and the processes, there's all the different technology that you might be using in your organization. You might have a CMMS that's different than your financial system. That's the case for us at Tacoma Water. You might be organizing data from your CMMS in a data lake that's separate from maybe your SCADA historian system. And so all these systems talking to one another can be complex and difficult in order to get to value decisions for your organization. Next slide. So that's where we are in the landscape of asset management. And so for us here at Tacoma Water, one of the challenges we faced with all those challenges is a lack of clear decision-making framework to establish our priorities. I'm sure many of you can relate to being in an organization that has many different priorities, and it can be difficult to determine what is your team, especially if you're a smaller team or a team of one, or where maybe asset management is another duty as assigned and you have a primary job that isn't asset management. So how do you establish what your priorities are for your asset management program that have that line of sight alignment with your enterprise strategy? And so for us at Tacoma Water, we wanted to establish our asset management governance structure. So the pyramid you see on the right here is how we've organized our governance structure, with our management team at the top putting together our asset management commitment. Our commitment is, and we use the IAM framework, is equivalent to an asset management policy, but given our kind of location in the city, establishing policies is really difficult, so we call our policy a commitment. And so our management team set that up, and with their blessing and support, we were able to establish an asset management steering team that sets our overall objectives for our asset management program, and then an asset management core team that establishes our strategies of how we're going to achieve those objectives. And then we've had for many, many years our asset management planning teams, which are what we call our voice of the assets. There are operators, maintainers that physically are in the field working and touching and operating our assets. And so they really support how we execute our strategies. And I'll share a little bit more about that on the next slide. So, thank you, Cello. So our asset management steering team is responsible for setting our asset management objectives. And when we were setting this up, we called this, if you have a roadmap, that was the kind of end goal, is having a roadmap like you see on the right. Where are we going? What's our destination? If we're going on a road trip, are we going to New York or are we going to San Francisco? And we can't go to both this year, so what's our priority? And that's how we describe our asset management objectives. And the steering team is comprised of 3 managers that are closest to the assets: our engineering, our maintenance, and an operations. What we are finding in our organization is often decisions were sent straight up to the superintendent to make these kind of prioritizing decisions, and that created what we call operational ineffectiveness. And that was a priority for the organization at the time, to really figure out how we can distribute decision making to the right level. And so that really helped support establishing a subset of the management team to guide our asset management decisions. And so that team that you see in the top left there creates what those objectives are. And in fact, it's really the asset management team that I supervise that has our recommendations that we bring to that team to put their fingerprints on. And we have a recommendation, and it makes the decision-making process pretty smooth. And that group then also approved and set up our asset management core team. And the core team is who establishes the strategies of how those objectives are going to be met. So going back to our roadmap example, if we're going to New York, are we going to go in the winter or are we going to go in the summer? Are we going to go by plane or are we going to go by car? That's how we have made the analogy of what the strategy is. And this group, the reason our assistant division manager level is on the core team is that they supervise the people and roles that really support us getting to that destination. So they have the authority to say, yes, my team has availability in the summer to take a plane to New York, or in this case, to create a level of service process, for example. And that led to then the establishment of our roadmap, which you see on the right. It's a pretty simple graphic, but it's been really, really effective for our team to know that these are activities that are sponsored at our highest level for us to be working on. And the steering team set a limit of no more than 3 objectives at a time, because not everything can be a priority. and we reevaluate this annually. And so this was all set up in 2020, was when we first established this governance structure. It was on January 1st, 2020, our organization reorganized right before we hit a lot of other challenges. And one of those reorganizations was moving asset management from being co-housed with our GIS team to engineering. And having this structure really helped us kind of figure out where we sit in the organization with that change. And what I've really appreciated about this governance structure is that it has been resilient to change. That steering team that you see there every member has changed since 2020 when we have established this, and still our structure is going strong, and we've been able to execute multiple objectives since 2020. The one that I'm most proud of is establishing a process for establishing levels of service. That's been something we've really struggled with that as an organization. And with the support of our governance structure, we're able to get that process established and are working on a system redundancy level of service now. That is what I have on asset management governance and how that's helped us with people, process, and tools to make improvements, to start small and make an improvement. And I don't know if I have time for questions, Chella, before handing it off to Nohemy.
Yes, let's see if there's. I don't see any questions in the chat line. It would be very helpful if you could place the questions there, because it's difficult to manage so many people being on the call. I don't see any in the chat line. Anybody?
I see Deborah.
Deborah's got her hand up.
Yeah.
Hi, thanks. Real quick. I think this is great, and your steering team makes the decisions and the core team implements, is that right?
The steering team sets our objectives, so we meet quarterly and say, yep, this is our target. We want to focus on right now documenting our asset lifecycle strategies by asset class. And then the core team says, I think we should focus on pump stations because we have a new pump station going in this area. So they help us establish the direction of where we go with that strategy. For both, though, really asset management, the team I supervise is bringing recommendations for each group to think about how they want to execute that. So for the objectives, when we establish those, our team prepares a charter that gives them a sense of this is a multi-year project or a 6-month project, and it's going to require these resources. And so the steering team says, that sounds great. And the core team says, okay, here's the people then that'll be in the roles to get this across the finish line, or here's the focus area that we want to focus on.
Thank you, that's great.
We have another question in the chat line. How many AMP teams do you have?
So right now we're sitting around 12 AMP teams. Those have gone through different iterations, as many as 16, but really 12 actively in 1 year, though we probably don't have more than 3 or 4 that we what we call activate. It used to be that they would meet regularly just to meet and check in, but we found that because we had a lot of crossover between those AMP teams, it made more sense to activate them to support specific roadmap activities. So for example, we are focusing on our life cycle replacement strategies, starting with pump stations. So then the pump station AMP team would be activated first.
One more question. Approximately how much time do O&M staff spend on those teams per month?
That's a great question, and not much because of the way that we've restructured our AMP teams since 2020, because we were getting that feedback that it wasn't a value add activity. So we're trying to make sure that it's really clear when and why we're activating those AMP teams. And the supervisor of our field operations is on that core team. So that's why we have that alignment, is they're in a position. They know if we're going to focus on this particular activity, it's going to require your O&M staff to support it, whereas other objectives on there, like our asset data creation, is going to be less intensive for our operations and more on our business services GIS team.
One more question. Are assets in office buildings such as HVAC and IT devices considered in this roadmap?
Great question. They are not. Tacoma Water is part of Tacoma Public Utilities, and so we're co-housed. My office here is with Tacoma Public Utilities, and all of our IT and HVAC is maintained at the TPU level and not within water. So we're fortunate that our fleet and IT and HVAC are all considered managed by TPU and not Tacoma Water.
Thank you. We will move forward. Just a second. We will move forward to our next speaker. This is Nohemy Revilla from SFPUC. Nohemy.
Yeah, good morning, everyone. I work for, as Sheila mentioned, for San Francisco Public Utilities Commission. I am a senior engineer, and we just have a group that we call Treatment Facilities Asset Management. I lead the team. I facilitate the meetings. I want to concentrate on the challenge that we had a couple of years ago. That we had some documented standards that were important for our asset management. The chart on the left, or the business process model notation that is, on the right on your screen, did not exist a couple of years ago. So we decided to start with asset onboarding. This is what it's depicted here. So we had a lot of, we had a written standard, but, it was very detailed, but there were not clear roles and responsibilities, and we didn't have the specific activities needed to be completed by who, and the decisions. So sometimes that resided on people's head, like, I work for maintenance planning, I have to do this, but whenever we had a project, the operations representative on that project didn't know exactly that, it wasn't that people's head or that person's head, but not people didn't know, right? So the challenge was that we had complicated process, and they were not very well documented. Responsibilities were not clearly defined, right? Sometimes, I didn't know for sure that what was my role. The decision-making process was not captured, and the needed process activities were not completely identified. So we still have a little bit of that challenge. But now with this chart, we can with this business process model, we can refer to it and say, see, this is what you have to do and when, and who has, you have to send this email to who, and all those kind of things. The next slide. So this slide shows the result from a 2019 project workshop. Where all the enterprises on the right, there were 40 utilities, it seems like, for representatives from 40 utilities. They find their main challenges that they were facing at the time. And then they classify these challenges into these 4 categories: capital project delivery, developing asset management plans and the risk management, and business case evaluation and prioritization of CIP projects. We still face all those things. And then they saw, they kind of categorize all those challenges in these 3 things. They were people, process, and technology. At the beginning of the workshop, they thought that technology was the main problem, but as you can see here, the challenges were mainly, on people and processes, and just a little bit of a technology problem. So as you can see, capturing the processes is very very important, documenting it and knowing how the process actually interact with the people and the technology is. As you can see, asset management is an enterprise function. And sorry, no, go back. And it is a challenge because collaboration can be difficult, right, across the business units. The data resides in many different systems. Like right now, we are facing a problem because many different silos decide on a project name, and the project number. And for some reason, I don't know why, because each of those silos kind of have their own way of capturing the number. It's such a basic function and such a basic thing for a project. But then, maintenance planning use that for our electronic time, right? Capturing that. And infrastructure uses that for some other thing. And then the people actually performing the project decides on using a different number. So, it's a very minor detail, but it's, that's why, we have to have collaboration between the different people. And then there's, and sometimes sub processes are typically independent of each other. So like, one activity that as like a different department or different group does, sometimes they say, this is my activity, please don't mess with it. Sometimes it's important to know, right? So next slide, hello. So the importance of, a business process model, it's very important because it captures the knowledge about the process. How the work is done, right? The different activities, how an activity transition to the next activity, or how the different people are involved with that particular activity, who is engaged in executing these processes, the resources, what type of technology you need, or what document you need for that particular activity, right? Or the decisions, sometimes you have to decide between two or many other activities depending on a question, on a decision you have to make, right? And again, the technology that enables that decision making process. And then also at the end, depending on some of the tools that you have for the model, you can measure your performance, you can track the performance, you can analyze whether that process is well documented or performed or captured. So there are many, there's artifacts that you can use. The BPMN is the business process model. It's a tool, and it can measure the level of maturity that you have, right? Like you can start with what you have right now, and then kind of try to see where you want to go, and assess the gap that you have between the existing and where you want to go, and and then you can capture who you need and what you need and all those things. Next slide. So these are the other tools, and it's similar to the previous slides. There is these tools that you can use to capture what you want, your goals, right? And define and describe all where you want to go, right? And then analyze what you want to document, or what documents you have at the moment, and then the participants who want to be involved in your process. So you can analyze the model or your process as it is right now, define the gap that you have between what you have and what you need or where you want to go, and later on define or design the the steps and the changes you need to get to where you want to be. So at the same time, you have to also include all these things, include the activities, the data, information, the decisions, the technologies, and all those things. So recently we went through this process and we discovered that because one of our process is not clearly, it doesn't have, all the activities that need to be done or who needs to be involved. We couldn't, our gap analysis it was very different from what we were and where we wanted to be, because we don't have all these things. So next slide. So we have used business process model or business process documentation currently at the wastewater enterprise to document asset onboarding. And it has been very successful. And we have also used the BPMN to capture the O&M manuals, the operations and maintenance manual review procedures. This has been very important because for the many different projects that we have, sometimes the engineers that are in charge, they don't follow the procedures. So if we capture that, we can have a very good deliverable, a very good product as an O&M manual for our assets, right, that are consistent all the time. And then we can reference that. We can it becomes like a map to follow for our different systems. And then also we have captured the asset warranty management, and this is important, right, because this is something that we need to make sure that the asset is in. Oh, there is a typo there. The asset is inspected before the warranty expiration date. And then the one important one is the asset naming and numbering convention. It's how it's the kind of the basic on when we onboard an asset too. So next slide. So the business process model is an ISO standard, and it ensures consistency across the different processes. One of the key takeaways that we have learned by using the business process modeling is that the stakeholders are engaged. They can, if sometimes, we tell them, you have to follow these activities. They, sometimes they say, well, I need this other activity, or, I need this process needs to be improved, right? So that way you engage them in the process development. There is a better communication because it's a standard, it's written, it's easier to follow. It's, the activities are very simple. Then it increases the process efficiency because, people know exactly what they need to do, and then they provide value. They provide knowledge about the current process, and they provide basis for engagement. And also it provides kind of a basis for improvement.
Thank you, Nohemy. I don't see any comments in the chat line. Please keep adding them. This was really informative, and I was hoping that Kaisra could take us a step further here.
Yes, good morning, everyone. Kaisra Osman with the Great Lakes Water Authority. I'm a manager with our Enterprise Asset Management Group, primarily involved in strategic planning for Great Lakes Water Authority. For those of you that don't know GLWA, short for Great Lakes Water Authority, We have a water and wastewater systems. We are a wholesale provider to various communities in the Southeast Michigan area. We serve about 3.8 million people, and we bifurcated from the Detroit Water and Sewage Department when it filed bankruptcy. So we call ourselves a 300-year-old infant, since we are managing assets that were built hundreds of years ago, at least some of them, and we're trying to bring them into the new era. And so that brings us to what is asset onboarding and why it was important for GLWA. As with everybody else, we also started our journey fairly recently, and we had many, many, many challenges. One of the key challenge is asset onboarding, because for whatever you need to do in asset management, data and information is key, and it's critical to developing any asset management program. And our data was really bad. We had a system, an antiquated system. We had duplicate assets. We had assets under the wrong hierarchy. Everybody entered them any which way they could. Water and wastewater were not synergized. We didn't have any consistency. And so in order for us to bring all of those together, we had to start developing, a proper hierarchy. We needed to make sure we're making sure we had all our assets in the system, accurate information, timely information for spare parts, for PM schedules. Of course, we had finance telling us, what are your assets, so that we can make sure the fixed asset registry is updated. And so it was chaos at GLWA. And so we decided what the asset onboarding process, making sure that the assets were in our systems on a timely basis, accurate and complete. We started this 3 years ago, believe it or not. It took us a year to actually get it together, put a pilot together, and start implementing it. And it has been one of the most successful programs at GLWA under our asset management. Next slide, Shallow. So where we are, if you can click again. So silos of excellence. This is where we were, I guess, way back when. Like I mentioned, poor asset data quality. We had lack of business processes, untimely, if ever, data entry. Some assets were not even in the system. So also notice for asset onboarding, not only do we need operations and maintenance to have good, consistent data that they can schedule their PM work on, but at the same time, we need asset management data to kind of look at budgets and look at what we need to refurbish or replace at what point in time. So none of our asset data was helping us do either of those jobs effectively. Can you click next? So our CMS system, the reason it, when it was first implemented, it was brought from DWSD. It was just kind of rolled out by IT. Nobody wanted to take ownership of the system from the business perspective. And so it was not configured properly. Nobody was really truly trained, or no training was consistently handled so that new hires and new people in the jobs would be able to use it effectively. Of course, it wasn't a mobile system since it was so old, and it just provided very inconsistent data. Next slide. So what needed to change? How many of you can identify with this cartoon where everything has to be last budget, right? Last minute. We have no budget, we have no guidelines, we don't have resources, but we need to get it done yesterday. And so this last minute asset onboarding led to very inaccurate, inconsistently untimely entry. And that's what we wanted to change with that asset onboarding process. Next slide. So what did we do? We actually, and again, coming back to what Nohemy and Jennie and have kind of alluded to also is collaboration, right? Bringing the teams together. We brought finance together, and I'll explain more of which teams we brought together to do this. But we developed an asset onboarding process that actually runs through the project lifecycle. So we started at the design phase. So this is primarily for CIP projects. We started at the design phase, where at the 60 or 70% design phase, we would have a workshop with the engineers, with the design consultants and or contractors, if it was a design build. And we actually worked through what are we changing, what are we replacing, what are we adding, what are we totally removing, what assets are in the system. We did some research, what are already in the system that need to be replaced. And so at least at that design phase, we created shells in our system for the assets that would be installed. And they could be installed in a year's time, a week's time, or 2 years' time, because some of these CIP projects span over several years. But we already had a handle on what assets we needed to touch during this asset onboarding process. And so part of that process then became where we had a asset turnover form. We shared it live with everybody. It was live data. Consultants updated the same form. We updated the same form with our asset IDs. The contractors updated the same form with manufacturer, model number, et cetera, asset specifications. It became a one-stop shop. Even finance could access the same document on that project and kind of see what it is that they needed to assetize for the fixed registry. So this collaboration really helped us with our asset onboarding through the entire project, because obviously it's only during construction that we can find out some of the asset specs. And then at the tail end of it, we made sure that we were uploading all the, or creating all the PM schedules. We were uploading all the O&M manuals in the system. Any BIM information was updated before the asset actually went into service. And during this time, it stayed as an inactive asset in the system until it went into service. And then that's at that point we activated in the system. So what this does is it's piecemealing all the information. It's not all information at the end. And we're now starting to understand our assets and understand what our needs are. And it has really helped. We didn't have a strategic change management system, but sort of what I did was, it was sort of informal, but I contacted individuals to bring them on this team. And then I brought them in little groups and then talked to them about it and then brought them into the larger groups. So there was a lot of collaboration and communication because everybody was in silos. Everybody thought they did a great job, or everybody thought this was too much. They have too much to do in their day job to be engaged in this. But in order to get their commitment to this process, it was very important to spend that time with them. Can you click on it, please, Cello? So why did we do all this? Again, it goes back to where we were. Really, we wanted to maintain data integrity. We wanted to allow our O&M staff to operate and maintain assets rather than going to look for them. Is it on this building? Is it under this process? Is it way out there under the HVAC when it should be under the incinerators? And then also, of course, good data over an asset's life cycle is invaluable for good decision making. And this is the reason why we went through this effort before even starting to attack some of the other things that we needed to do. By the way, during this process, at the same time, we were building our strategic asset management plan. So by the time that plan got done, this was in the works. So it really worked out. Next slide. Let me know if I'm talking too fast.
No, you're good.
So how did we do it? So again, like I said, communication, collaboration, commitment. The 3 C's of change. Very, very important. We engaged the project engineers. We engaged the engineering consultants and contractors. We engaged the asset management, local asset management teams, which weren't really designed as asset management teams. It wasn't part of the day job, but they were doing some asset management. We kind of brought them into the picture. We had us as the enterprise asset management group facilitating all of this. We brought from finance, we brought the logistics and materials people in so that they could look at inventory. We brought the CAFR in so that they could look at what they need to assetize. We also brought our financial reporting team that actually went out and put their financial asset tags on the assets so that, we had 3 groups in finance part of these workshops. And of course, we had our GIS team if and when we needed updates to our assets in our GIS system. So it was a large team, but they were all in the same meetings. We had 2 or 3 workshops that all got to understand what was building. They all understood what the process was, and they were able to get the information they need to get their jobs done. So communication, collaboration, and commitment, very, very key, very, very critical to break those silos, bring people together. This was probably one of the hardest projects that we did. And we had to also change a lot of the language on our asset turnover spec that went out with the RFBs. And so that kind of had to go simultaneously as we were doing this. Next slide, Joan, please. So our key takeaways. So I'm going to go through our good, the bad, and the ugly. The great thing is it has served as a basis for breaking silos. People are now talking with each other. We're making sure the assets and the systems are created on a timely basis. It has dictated not just what we do for data integrity, but how we do it, which was very key to bring people engaged and open to this. And of course, it's opening up a path to better informed decision making. We currently have a project focused or project driven CIP. We are with this process and with our new system that we're currently implementing, we're trying to drive through where we have an asset driven CIP. So that's our goal for asset management at GLWA, and we're really excited. We're on our way to get there. The bad, continuous process improvements. Obviously, this process has gone through various gyrations. We hire new people, training them. We have to make sure we stay on top of that because stagnation is definitely not an option for us. And the ugly is getting there was a big lift. Staying there is difficult. You have to be continuously on top of things, on top of people, auditing the assets. Of course, now we have a new system implementation, and much of what we're doing is processes are going to change somewhat. Not necessarily the business process itself, but the system process and how we manage our assets in our new system.
Thank you, Kaisra. There are some questions. And there is a question. Does your EAM asset register match your financial asset register and same listing of assets?
So it does not. And that was one of the challenges we realized during the asset onboarding process. We're probably never going to get there because finance they've got buckets. They have a pump that they're going to put in a bucket and amortize it. Whereas we may break down the pump by the valve, the motor, and into 3 pieces. However, with our new system, we are looking at that again. Our new system does have a fixed asset ID, UDF. And so we're going to start trying to match. If they have one pump with one fixed asset number, and if we put that in all the 3 components of our one asset, we're going to be able to match it. I know the values are not going to match because, it's depreciation on the fixed asset registry is really different from how we're looking at it through maintenance and risk. And so, but we are hopefully going to get there with our new system.
There are more questions, but what we'll do is we will communicate these answers back in writing and follow up with a link to the recording of this meeting as well. And I want to say that I very much appreciate all of the speakers. Thank you very much. And we're almost out of time. We're planning our next meeting for late January or early February, and we will answer the questions via email because people, I'm sure, have other meetings. So thank you all very much, and we'll see you hopefully at our next meeting. And also wonderful job for all the speakers. Thank you very much. Take care.